All right, so this panel is really focused on the technology, the infrastructure technology that's needed to do your job. So essentially technologies for implementation of systems. We'll talk, you saw in the earlier presentation from David and Duncan, LabVIEW, so I won't go into a lot of technical details, but user interfaces and then software for control, computation, communication. Really focusing around this real-time systems. Then as we all know, these systems have actuators. So we are very pleased to have Ray Buckman from UT Dallas with some very exciting news for us. He's going to tell us how this really hard problem of and mobile machines, whether it's a robot or what, having the ability to move with the ability to, muscle, so artificial muscle. So that'll be pretty exciting. And then we got Sharon Wood. She's the chair at the Civil Engineering, Architectural and Environmental Engineering at UT. And she's going to talk about sensors. That's the other side of the coin, actuators and sensors, and how we are looking at monitoring the infrastructure for our bridges and the like. And then Mark Spong, Dean of Engineering from UT Dallas, is going to tie it all together, talking about robots. And it turns out robots is a really good stand-in for kind of, it has all these things. It has to sense the environment, it has to have actuators, sensors, so it has all the elements, and that's why it's turned out to be such an exciting tool for teaching kids, because they're learning, they may not realize at the time, the basic concepts, all the way from the math of what it takes to calculate pass and things like that, to the sensing and control and software. So that they're learning all the concepts without it being just structured learning. It's more, can be highly unstructured. So robots turns out to be a very exciting area for tying all these elements together. So we'll hear about that. It was Paul's vision for this session and how it's organized, and he recommended Ray. He thought very highly of him, so it's good to see that Ray was able to join us today in his talk. And I'm gonna say a few words to that. Barbara had a very fixed format. He asked us. I'm going to take a little liberty on that format, but basically, since we already had a presentation on LabVIEW, but look at it in a bigger business picture of our technology and how it fits. So I'm going to start with the barriers. If you've been looking at general press, there's been a lot of articles talking about, what happened in this big meltdown. And one of them was in Business Week, and it spoke of how we simply didn't have enough of the right kinds of innovation. Too much was focused on innovation on Wall Street and not enough in the technologies that we really needed for energy, medicine, and the like. So that's a frame that I think is very important to understand. And the basic barriers here is society's willingness to do it. We see things like nuclear energy, which is an obvious answer for one piece of the puzzle. Why don't we work on it? I know with the technology we have available, we can make very safe and low-cost nuclear power plants, but we're not doing it because we don't have the societal will to do that. So this in itself is an issue. So another Time Magazine had an article on Thomas Edison, and the real goal of this article was to talk about, inspire people to look at things the way Thomas Edison did. This innovation, this level of innovation, there's lots of opportunities. And these are hard problems that we're trying to solve, but we need this level of enthusiasm and innovation. And here's Tom Edison saying, a minor invention every 10 days and a big thing every 6 months or so. And then they also showed a page out of his notebook. And it's just really awesome. This is just one page, and things on the phonograph and all these different things he invented. We need that attitude of innovation in the way we're operating. What struck me, too, is that you heard earlier in David and Duncan's talk about the literally tens of thousands of things folks are doing with our tools. So I decided to write a similar list to Edison's to sort of show this point. You name almost anything, whether it's a Tesla race car or space exploration or batteries for electric cars, or my favorite actually is one that was invented right here in Texas, and that's Steve Holdridge talked about it, fracking. Fracking is very controversial out in society, yet it can be quite safe, and it is safe. And it can be made more safe. If somebody thinks it needs to be safe, okay, let's do that. But quit trying to shut it down. So we have a serious problem in that the hard problems don't get solved because society simply doesn't have the will to do it. And I think that's the biggest barrier of all in this whole process. So you heard about LabVIEW, and our goal is in one of my talks at NI Week, we have NI Week where I have 3,000 of our customers come into Austin, Texas and hear about our products and share their stories and success stories, is to create a tool that makes everybody be able to operate like Edison. Obviously, things have gotten a lot more complicated. So we have to get rid of that complexity. We have to make it possible where small teams, once again, can be successful in what they do. So that's our goal, that's our vision, and it's a tight integration, as you heard, between hardware and software for real-time building real-time systems, whether they're test and measurement systems or automation systems. Either way, we're able to work in real time. That's very unique, and we have proven that we can cut the time to development by a factor of 10 or more. Many times people getting what would take a couple of years to do done in a matter of days, weeks, or months. So that's really the goal. I call it the return of Edison, where we can get the productivity up, where this ever-shrinking workforce that we have for doing science and engineering can be productive and get the right things done. You also heard how, and I think the National Academy's Engineering Grand Challenges is a good place to look for ideas on what we ought to be working with. Obviously, they put a lot of time into that. National Instruments is involved in every one of them. So we are able to even take, as was mentioned, the tokamak, which is my pet favorite. We got a number of projects going on there. Able to do these things with a tool that makes scientists and engineers more productive.